Thank you for joining today. So, who am I and who are we? My name is Marloes Reining, and I'm going to be your facilitator today. I'm one of the directors of Regenerative Collaborative of South Africa, the RCSA for short. We are a non-profit organization focused on transforming the built environment into a regenerative one. If you want to see one of the previous webinars, they are now all uploaded. So please subscribe if you enjoy the videos. That would help us a lot in finding sponsorship, because the more followers we have, the better we can sell it. Also follow us on our social media channels, on LinkedIn, YouTube, Eventbrite. Always good to hear and have a good following. As I said, it really helps us finding sponsors if we have a good following going. Sponsor for today. We're really grateful that we have a sponsor for today. The sponsorship goes towards the validation of the CPD points, and without the sponsor, we couldn't make these webinars possible. So I'm going to show a quick video, and then I'm going to talk to you about ENVIROCRETE while the video is playing. So ENVIROCRETE is a South African company at the forefront of sustainable construction, and their commitment to building a greener future perfectly aligns with what we are trying to do at this webinar. ENVIROCRETE's mission is to deliver innovative and ecological building solutions that not only sustainable but also affordable. They achieve this by employing a unique construction system that combines two key elements. One is bioclimatic architecture. The design approach prioritizes energy efficiency by harnessing natural elements like sunlight and ventilation to maximize reliance on conventional heating and cooling system. And the second system is the off-site prefabrication, as you can see in the video. By prefabricating building components in a controlled environment, ENVIROCRETE reduces waste, streamlines construction processes, and ensures consistent quality. This combination allows ENVIROCRETE to construct homes that are not only environmental friendly but also cost effective to build and maintain. ENVIROCRETE's dedication to sustainability extends beyond their building methods. They are committed to uplifting the lives of South Africans, particularly in the underserved communities. So they are trying to do that by delivering affordable housing solutions. ENVIROCRETE's efficient construction system allows them to create high-quality green homes at a competitive price point, making sustainable living more accessible. They also focus on uplifting communities. ENVIROCRETE is passionate about creating a positive social change. Their innovative building systems solutions can be used for various projects, including affordable housing developments that improve living standards for residents. By championing sustainable and affordable construction, ENVIROCRETE is paving the way for a greener and more equitable future of South Africa. So if you are interested in learning more about ENVIROCRETE's innovative building systems and their commitment to sustainable development in South Africa, I encourage you to visit their website. There you'll find detailed information about their projects, technologies, and their vision for a sustainable future. And thank you again to ENVIROCRETE. Thank you so much for your generous sponsorship. We really, really appreciate it, any support to these webinars. So please, show some hands for ENVIROCRETE for making this happen. So we're just gonna finish the video before we're gonna move on. So you can see the fire safety is great. And it's all assembled on site. I had opportunity to actually see this house a couple of years ago already, and yeah, it's worthwhile. Please reach out to them if you want to know more about their product, want to know more about the company, and if you can go and have a view at the pilot house that they have built. Right, thanks again. Great, so now over to the talk of today, which is around bioclimatic design and architecture. We have today Yogesh Gooljar, and he is definitely one of the more esteemed colleagues in the industry. Yogesh completed his Bachelor's of Science in Electrical Mechanical Engineering at the University of Cape Town. He then worked as a building services consulting engineer for an international multidisciplinary team, gaining experience in the air conditioning, ventilation and heating, wet services, fire protection and refrigeration systems across various sectors. And since 2015, he has been part of the leadership team at PJC and Partners, and basically running the company. So PJC Peru Consulting is the sustainability consulting company based in Cape Town. So, Yogesh, I'm going to hand over to you.
Hi, everyone. Thank you for pitching up on the afternoon before the long weekend. So well done to everyone who made it today. Hopefully, I'm going to try keep it a little bit interesting, and hopefully it's a bit inspiring. So hopefully make it worth everyone's time for being here this afternoon. Let's get into it. So a little bit, I think Malu's explained a little bit, gave us a very good introduction. Thank you for that. But it wouldn't be fair to me to give a presentation without talking a little bit about PJC. So this is just one slide. So we've been around for quite a number of years. I think this year's will be about 20 years. And we've been growing, reducing, growing dynamically over the past 20 years, but we've always been a mix of engineers, architects, and scientists. And we've done various types of projects, from single owner residential to large mixed use developments. And we'd really enjoy collaborating with our peers and different industry bodies. And that's the reason why we are now here giving a presentation for RCSA. And what do we typically do? So this is very fitting because bioclimatic performance is essentially in everything we do. Our services are kind of various aspects of it, but we try to keep bioclimatic performance as the core around what we do across all our services. And in this case, it's under our research and education wing, in this case for the presentation. So for today, I am going to try, hopefully make it a little bit different. So this is not, because everyone could kind of Google bioclimatic design and get what it's about. So I'll try to keep it a little bit different. I'm trying to explain the bioclimatic concept itself, deconstruct the word itself, and go through the bio side of it and our human senses, go through the climate side of it, and we'll take a quick break, pause for a poll question, and then we'll carry on with a bit of practical design questions we've solved, and a little story I made up about Andy and Mindy. And then obviously at the end, some takeouts about the presentation. So what's bioclimatic? So as the word itself kind of suggests, bioclimatic consists of bio, which is from biology, and climatic for climate conditions. So essentially it's about the relationship of climate and us as human beings in the built environment. The word itself, bioclimatic, was coined in the early 20th century, and it was not really about buildings at that time. It was more about the study of plants and animals and the climate change effects on plants and animals. But as the years went on, the context bioclimatic started applying to the built environment as well. Bioclimatic architecture has always been around. It's just the word became coined officially in the early 10th century, but it's been around from prehistory. Prehistory, it was when we were cavemen to now, even in the future, to living buildings, regenerative buildings, and net positive buildings. It's been around when we were doing vernacular buildings, where we would build buildings based on observation and experience, to kind of our passive design strategies, which got developed through technologies and natural sciences. The main thing is the context change, but bioclimatic architecture was always around. So what is the changing context? So if we think about prehistory, it was about human beings trying to live somewhere where they could be safe from the elements and safe from animals. It was for security and for comfort. Then architecture as a science and art starts getting introduced, technology was introduced, and technology itself evolved, and the context changed again when ecology and other natural sciences and social sciences getting involved with, and it all fed into this concept, this bioclimatic concept. And now with social sciences and ecology and natural sciences all being part of the concept, it's how we are transitioning to living buildings and regenerative buildings. So why biology? Why do we care? Why do we say, why is it even part of this concept? Because in order to design anything where we live and work and live, we have to understand us and what does it mean to be a human being in a built environment. So because buildings should serve us rather than the other way around. There's no point designing and building buildings which are super smart or super energy efficient if they don't work for us. And understanding us comes from our senses and a few other things like the individual as I or the we as a group of people. And I'm going to also intuition, and I'll explain a little bit about these different senses and what it means when I talk about intuition. So every person is an individual and different in all respects of with all other people on earth, like factors like age, sex, skin color, or external differences. But there are also differences in terms of cultural backgrounds, education, attitudes, and behavior. Going beyond that, there's also some of us may appear nervous or anxious, and some of us may appear more mentally and physically well. So it's important to understand the we, because when we do it's not one person who uses a building, it's multiple people who use any kind of building. And there's a saying, I'm not sure who is it from, but I really like it. It says the same fire that melts the butter also hardens the egg, which means the same stimuli which can be applied to different people, which produces different effects. And this is what a building is. The individual as I, so a person is not only different to other people, but they also develop and changes over time. And this is important to note for us, especially in the building context, because we are different persons at different times of the day. We feel differently, and in winter and summer, one person can behave differently in the different scenarios, in the different situations. So it's important to understand how that interplay with the buildings when you design for summer versus winter, for example, or in the morning to the afternoon. Our needs, so this is very simple. So buildings needs to respond to our needs. So we've gone, as we've seen through the evolution of bioclimatic architecture, we've gone beyond just functionality. We've gone beyond just being a safe, a secure, security place where we could be safe from the elements and wild animals. Now getting to the human senses itself. So obviously everything we do around us is a factor of one or two or multiple of our senses. So seeing, visual comfort, and visual comfort is not just about lighting or daylighting. It's also how we interpret what we see. Not everyone have the same visual acumen to see it. You can, multiple people can see, look at the same thing and interpret it different ways. And the way lighting or color works also gets interpreted in different ways. So understanding that helps to design buildings which try to have the best visual comfort or the optimum visual comfort for the majority of the occupants using the building. A very quick kind of, which everyone kind of will know about color, when I'm sure everyone have seen how color affects our perception. When you paint ceilings, walls, or floors different colors, it gives a different perception of the space. And this, you can replicate that very easily yourself. You don't have to go find a room to paint. So for example, in the office, on the left-hand side, you use chalk, you use a piece of paper, and you can easily mimic that perception. And you can give it yourself a try and think about it before kind of going into big simulations or going too far ahead down the design, getting an idea what it would look like. And then we've done that in the office with fairly good success. On the left, you'll see at the bottom of the image, there's also a little bird box with a cutout. Later on in the presentation, I'll show you an example of what that means in terms of light and visual comfort. Hearing, which is the acoustic comfort. I'm not going to focus too much in it in this presentation. We're going to talk mostly about visual comfort and thermal comfort. But I just wanted to touch on it because it is also one of our human senses. Similarly to how we see, we differ very strongly in our ability to hear. For some people with a little practice, we can distinguish between individual tones from a mixture of frequencies, some more than others. And this affects our acoustic comfort. Why is it important? Is a very simple example would be double glazing or acoustic glass in buildings. I mean, this understanding that helps to design buildings which are suited for a particular purpose. Feeling, so the feeling, it's mostly about the thermal comfort in this case, and it's mostly about the skin. The skin is the most versatile human sexual organ. Like its receptors for cold and heat. We do not have a better measuring instrument like this artificial one. We don't have a mechanical electrical measuring instrument like our skin. It is so versatile and so accurate to us. And understanding how heat or cold react with our skin is very important. Like, how do we lose heat? How do we feel when it's too cold? How do we feel when it's too hot? What happens when we change a certain aspect of the environment around us with regards to thermal comfort? A very good way to look at that is to look how our body temperature from our core to our extremities changes in very different ambient conditions. So at 35 degrees, most of our core tends to be a very uniform temperature. 20 degrees, which is your normal, considered the normal condition, this is your like stable condition where your core is trying to maintain that 37.8 degrees to be healthy, to still be in good health. And then cold, you'll notice the ears and the fingers and your feet starts becoming very blue, and that's where it becomes a problem for your extremities, but your body still tries to protect you by keeping your core at a warmer temperature. And typically, if you are sitting down and you are at rest at ambient temperature, most of your heat loss happens in the form of radiation. And this is very important to understand because in the legacy of buildings since the 70s has been through air-based air conditioning, where we are only affecting 33% of that heat loss, heat gain with our body. And we're not looking at the 46% added. And this is where when you sit next to a hot glass, you can feel the heat. When you sit next to a cold glass, you can feel cold. It's because the radiation is much more impactful to your thermal comfort. Smell, so it's not really going to focus on it in this presentation, but again, as a human sense, it's important to note. And the smell in this case goes beyond of odors or pleasant smell. It also involves carbon dioxide production. Fun fact is every liter of carbon dioxide given off requires 1 cubic meters of fresh air, and it's to maintain a very healthy environment. So it tells you if you're breathing out a liter of carbon dioxide, you'll need to make sure there's 1 cubic meters of fresh air coming into the space for you to be healthy and productive. And the nose is really an amazing organ. It helps us. It's the quickest pathway to our emotions, and people would know that if you're walking somewhere and you pick up a smell, it kind of brings back memories and emotions always, and that's important to note when you are in a space. Intuition. So not quite a human sense, but it's very core to who we are as human beings. And as Albert Einstein said, the only real valuable thing is intuition. And on the right is just one of the images I'm sure many people would have seen online, where you can design and think about your design and do all the calculations you could have done to get your design right. But the user experience will be very different to how you've designed it, because you've ignored the intuition of people. And I know in the building industry as professional, we try to quantify things as much as possible. It's the same thing as saying, okay, well, let's design a building, put AC in, and there's the whole adage of 22 degrees air temperature, and people should be comfortable. But thermal comfort is much more than that. And as we've seen, the human body is much more than a physical measuring instrument. And it's important to understand that, to understand intuition, so that we approach problems from that perspective as well. I've tried to touch a little bit on the biology side of it, but because it's bioclimatic, I'd like to touch a little bit on the climate side of it. To understand climate, I think what I usually like to start with is to understand, let's look at the local context. What you're seeing on the screen with the pie charts is actually data, actual climate data from Cape Town. So I took hourly data from a weather file in Cape Town, and this is 8,760 hours. And I've said, okay, how many of those hours do we have daylight? And it's South African Cape Town is usually 50-50. And I've said, out of those hours, how many are within a certain temperature band and relative humidity band, which we'll consider comfort band. And it's about 31% or so. And then if we overlap that, you get what I think Chilu from Solid Green calls the natural hours. And it's I really like that term. The natural hours is very important for us to consider, which means for those natural hours, we should not be reducing those natural hours in any building. Otherwise, we're not doing our job properly. And the idea is to increase those natural hours without having too much of an energy penalty, if any at all. And the whole thing is around the biology and the climate. So it's around to not compete against the natural forces, which is our climate, and our biological rhythms, which is our biology. And that's the whole essence of bioclimatic architecture in a way. So what can climate tell us upfront? So climate in general has a lot of data attached to it. We always look at the climate, but climate is full of data. It's got temperature data, relative humidity data, radiation, wind, all kind of data. So it can tell us a lot of information upfront. It can tell us whether in this context we can have natural ventilation, so we should design our buildings more towards that. It can tell us, do we need to have a mix of active and passive systems? It can tell us, can we use the day and night temperature differences to implement certain technologies, or use that even on the thermal mass of the building? So there's a lot of things we can extract from just the climate data itself without even having a building shape at the beginning. We can't talk about the climate without understanding the sun. The sun is one of the biggest factor influencing any climate. Apart from having beautiful pictures, photographic pictures, it contains an extreme amount of data we can harness from the sun. It produces energy, it produces light, it produces heat, and it gives life to everything around us. So what is it we can extract from the sun? So this is a very simple example, again, for Cape Town. So this is a very example of Cape Town. So the top measures, the rows, what we call the solar radiation rows, is showing solar radiation in Cape Town for summer. So from November to April, and it's got separated into diffuse and direct. And the difference between diffuse and direct is direct radiation is the sun rays you can feel directly, and it has one path from the sun directly to the ground, and diffuse is all the reflected kind of radiation from the ground or through the clouds, and in any way it's not direct from the sun, any kind of rays which are not direct to the sun. And what's important to note here is diffuse radiation on all orientations is more or less the same, whereas direct radiation is mostly concentrated on the north, east, and west, but not on the south. And most architects, a building professional knows, yes, in the south, we don't put any shading in Cape Town. And it's true, but it's also more than that, because yes, the shading will affect your direct radiation, but your diffuse radiation is then not, it's not about shading, it's about the glazing. And that's a lesson out of it. From simple studying the sun, we can immediately get lessons for glazing and shading. And when we talk about shading, so this is a very simple example of understanding the sun and our latitude where we are. I'm not going to spend too much time on it, but I just want to show that in Cape Town, again, on a north facade, you've got your sun at a certain angle in summer and in winter, and you can easily, based on simple trigonometry and maths, you can easily get an average how deep your shading should be. So that's a very basic example. But with the same maths, you can get a different type of shading with the same shading effect. And that's really understanding the basics, the first principles of the sun and how it looks like, and it has different angles across different latitudes in the world. And it helps to inform design bioclimatic architecture before we even go and design buildings with a shape. More on the sun. So apart from shading, the sun provides us light, and daylight is a great proxy, because light is a very curious thing. You can't feel it, you can't smell it, you can't hear it, but you can see what it does. And it's a very good proxy. One doesn't have to have all the nicest, latest software to know what, by looking at what light is doing, you have some sort of idea how to think about your shading and about your glazing. And it's a very good exercise to do for everyone thinking about bioclimatic design. And a very simple way, practical way to do this is what I was talking about before with the box. So what you're looking at your screen is an experiment sometimes we've done in the office, where you take a shoe box. Everyone has bought a pair of shoes before and have got a shoe box. You cut holes in it, different positions, paint on the inside of it on one side, or leave it open and make a small hole on the one end of it, and then peek through it. So this is obviously on the right-hand side, we've got a small fisheye lens we've put in there. We've took a photo of it, and it can gives you a very immediate feel for any kind of ideas you may have, which you may not have the simulation tools to test, but it gives you a very practical, easy way to test your ideas. And it's a very simple thing to do. It doesn't require any skill. It just requires a shoebox and a pair of scissors and a few maybe paint brushes. And the climate, obviously, apart from the sun, the wind is much more complex, because the wind is very local context. Typically, wind data is more on a macro level. On a micro level around the buildings, it's much more complex. But it also, looking at it, also allows you to kind of make some very good guess estimates, some educated guess around it. And there are tools available which we use, which you can overlay your wind data over temperature or over sun, and it gives you an idea how to think about it. And the main thing is you understand how to use wind as an opportunity and where wind could be a limitation. So for example, in Cape Town, in summer, we would love to use natural ventilation all the time, but we know we've got the Cape Doctor, the southeaster, which blows in and will completely destroy your window if you leave it open. That's the idea around it, is have enough information to know when it's an opportunity and when it's a limitation, and also when to turn the limitation into an opportunity. It's the way of thinking about the first principles about it. Just wanted to pause a little bit to have a quick poll question to just provide a little bit of a break. I have a question here on the screen, and I think Maluz will have it in the Google Meet poll.
It's live. Give us your options or your votes. So there's 3 votes for sight, 2 votes for touch, 1 vote for smell, 9 votes from option 1 to 3, 6 votes for option 1 to 4, and 9 votes for all of the above.
Wow, it's quite diverse.
It's quite diverse, yes.
So I was thinking when I was doing this presentation, so instead of showing bioclimatic strategies and going through the basics of it, we could talk around all of it, orientation and all of those things over a long time. But I thought instead of doing that, I actually want to talk more about intuition, about why it's important to think about the way we approach things rather than just saying there's a strategy, there's the software, and let's just simulate stuff to get answers. And to do that, I thought about a story of Andy and Mindy. So Andy and Mindy are architects. They want to design green buildings, and software was the only barrier. So they learned to use one. The software, the tool was amazing. It could do a million things, and now they are unstoppable. But are they unstoppable? So if we look at Andy, so Andy says to the software, here's my building, run the green options. The software gives them, here's our 50 options. Andy says, wow, which one do I choose? The software says, here's 10 more options down to narrow it down. And he said, well, that's great. I'm still confused. And the software is like, here's the single best option. And then they say, are you sure? The software was like, well, you're the one who press calculate. You should know. And then the conclusion was, well, like, it's too technical, too time consuming. So I'm better off without the tool. At least I'm designing based on my expertise. But if we look at Mindy's like, here's my building. But instead of saying run the green options, Mindy says, well, check if roof insulation is effective. So give me the temperature output for the room for one summer week. And the software gives what Mindy asks. And Mindy notices something and says, well, why is the living room cooler than the bedroom? The details are the same. And the software says, oh, there's a modeling error. We didn't put insulation in that room, so we'll run again. And then from that results, Mindy says, well, it's clear insulation is better. So let's just now run 4 options of the different thicknesses. And out of that, Mindy finds that option 3 is the best in terms of optimizing costs and energy savings. So goes back to the team to work on the roof details based on the insulation thickness. And what happened out of that is both of them use the same software and have concluded differently. So the moral is questions matter as much as tools and software is important, but knowing how to use the software and asking the right question and knowing how to approach things also matters, sometimes more than just the software and the tools. And that's the essence which I'm trying to get to bioclimatic architecture, is understanding first principles, is understanding what does it mean for the people and the building in that context. And Mindy's advice to Andy would be, well, let's define the question and the metric so that we know what we are evaluating. Let's anticipate the outcome based on the first principles, building science principles. And then let's use the software then for guidance and answers and to refine our solution. And that's in a nutshell what we're trying to do. We're trying to understand the first principles of bioclimatic architecture and applying it to solve our problems and our design questions, and hopefully along the way get buildings which are energy efficient and work for us. So I'll give a few examples which we've kind of done in the office. I haven't put too many examples here, just I've got, I think, 3 or so examples in here around different contexts. And the first one is a daylighting problem. This was a building where it wasn't about design. It wasn't really about the design. It was about compliance. So, which is quite rare in South Africa, where this building actually didn't pass municipal compliance because the building officer came back and said, well, it looks like the building's not going to have any light in. And in South Africa, we don't actually have a statutory regulation on daylight, but it still got raised as an issue. So we got approached and we kind of looked, okay, internationally, and what are the metrics we could use? Like, what are the performance indicators? And typically you've got 3 different type of metrics which you use. But then it's not enough to know the metrics. It's about to know what are the indicators, what are the hierarchy of comfort with regards to the different spaces, what are the benchmarks to use. And it's important to know that. And you can run the simulations for each of those metrics. You, in this case, we've run the simulations across all the different spaces for the 3 different metrics we've identified. And the 2 gray in the middle here on the left is the design, the actual design, and on the right is the design with some recommendations we've provided. And in this case, the mean lux to the design is about 495. The recommendation with our recommendation became to 928. And it's using a little bit of what we understand about light and how light behave to provide those recommendations. And the same thing around other different metrics. So this is spatial daylight autonomy. And this metric, just in case a lot of people don't know, daylight is not just about how much lux levels we've got or how much light we've got. It's also about distribution. Distribution of light is also very important so that we don't have glare, we don't have contrast, and there's enough light across the floor plate so that we are safe. There's no dark spots, and depending on how, obviously the context is important. Some contexts like museums and specialized contexts, you do want darker areas in some spots, and understanding how light behaves help us to design for all these kind of spaces. That's just a different metric. But at the end, essentially, the idea is to show one where you're not meeting compliance in a certain way, but through recommendations, you can meet compliance through. And that's very simple example of very simple things, just using daylight, but understanding how daylight works, understanding the different metrics of daylight and how to apply it, how people see it and interpret it. It's very important because our metrics wasn't just about lux levels, it was also about spatial distribution. The other one is glazing. So this is a very, very typical question from which we address in a lot of projects. So what glazing should we use on our buildings? And again, enough people have done it enough to know from gut feel or in this climate, use this or use that. In this case, there was more than just interpretation of glazing. It was also acoustic was also quite a primary factor to it. The different kind of orientations, the what we use for it, and the cost was also in this one. Cost was also a big factor. So understanding how this relate to cost can be, because it's not about getting the best glazing for everywhere around the building. It's knowing where we need it and where we don't need it. And it's important to understand, if you look at the top left side of the slide, you'll see this image about how light from the sun go through glass. And this is important to know. The sun shoots out short wave and long wave radiation towards a building, but glass converts every short wave radiation. So short wave radiation is visible light, UV and UV, into long wave, which is infrared, which is heat, and traps it inside. Once the light goes through, it gets converted to long wave, and it cannot go back out through the window. And this is the greenhouse effect. This is essentially the greenhouse effect. And this is why when you have glass enclosed spaces, it gains heat when you expose it to sunlight. And it's just about knowing, it's just a simple fact that the glass converts every single shortwave radiation into long wave radiation. And knowing that helps you to also understand, if you have a low E coating, it prevents then that light from even going inside and be converted. And it also helps you to understand, if you have just double glazing without any low E coating, it actually becomes an insulator. So when your light goes through your double glazing, it can't go back out, and your double glazing is an insulating material, which means now your heat inside is increasing. And the difference of knowing all of this is very important when you do various kind of simulations about temperatures and radiation. It helps you to identify, you don't have to have one solution everywhere. As long as you can balance your costs, your aesthetic, and the different, your acoustic requirements, you are able to play with the building. You are able to think about it differently and say, okay, if I put this, if I do a certain shading response here, I can put a different type of glazing. I might not need it in other places, and it all fits within the budget while keeping the same kind of philosophy, architectural philosophy. And it's all about understanding, again, the first principles of sunlight and radiation. So this one was a glare question. In this case, the building was built already, and the tenants had moved in, single tenant kind of building. They've moved in. They have a reception desk, as we've seen in most commercial buildings, in the atrium. And they had a glare problem at the reception desk. It was unworkable. Everyone sitting at the reception area just had glare in their eyes, on their screens, and it was unworkable. And the easiest option would be, okay, they put automated blinds all along the atrium facade, long automated atrium down. And it had to be automated because the span of it, the extent of it, is you can't do it manual. And that inherently carries a lot of cost to do after the building is being built. So what we did is we went there, we used some tools, which basic phones, basic first principles ideas about where the sun path is, and found out, when does the glare open, at what time does it happen, and what are the alternate solutions you could approach to that. And what happened was we gave a solution, proposed a solutions, which was, let's build an architectural feature, an interior design feature around the reception desk, which blocks the sunlight when it's a problem, and also have a mix of having the blinds only where you needed them, where the feature around the desk doesn't do the work we needed to do. And it became a very, very nice hybrid solution where you saving costs primarily by not having blinds, those long extended blinds everywhere, and having only when you need it, and having a little bit of an interior design kind of feature around the reception desk. So this is not quite a particularly practical kind of problem we've addressed, but I wanted to show this as a kind of if you understand the first principles, you can think a little bit outside the box. So we were approached for a competition by this German firm, and they wanted us to be part of their team, and for a competition in the north of Germany, where we looked at the climate. In winter, it's -5 to 10 degrees, relative humidity around, and rain to about 80 to 90%, very low direct solar radiation. In summer, up to 30 degrees with relative humidity up to 85%, which means it's hot and humid with very high direct solar radiation, very extreme summer and winter climates. And when we were chatting to the team, to the structural engineers, to the mechanical engineers and the architects, and we started brainstorming some ideas, and we had this idea of box in the box kind of ideas. How can you think about it differently? So we started looking around. So the top kind of left photo is using fabric, a very specialized fabric on the external, and having a very different kind of internal building, which is glaze or different kind of conditions. The middle thing is actually a concept for the Google headquarters, where it had this massive dome, transparent dome design with, and then a campus under it, a full campus under it. And then below, right at the bottom, it's a university building where they had this kind of facade, a very translucent kind of facade all around. And that allows you to create a semi-stable environment underneath the first kind of layer, and allows your inner building to be built very cheaply in terms of single glazing. And all your outer layers doing is kind of protecting you from the elements. And this was like kind of the concept which went around through, like, you know, using first principles. What do we need to think about? What do we need to care? And we spend a lot of time on the first principles before you even go towards then doing very simple modeling to test your ideas. And that helps when you understand what the sun do, what the wind does around in the different climates. I just wanted to give a bit of takeouts, like what I was trying to get to is over the presentation. So one is knowing your first principles about everything, about your climate, about design, whatever you're trying to do in terms of biology or climate. Trust the intuition of the local context, investigate it by talking to the people and how they would like, because there's always that we can think about design in a very quantitative way, but it's always good to know the local context. Ask the right questions, find out what the right questions are, than just going to a software and say, let me just simulate the hell out of it. This is something, model only when necessary for guidance and to validate assumptions and answers. This is something very important, which some professor from a German university told us. Like, do not model if you don't need to. If you can do a calculation on the back of a Soviet or like any kind of matchbox calculations, do that first. And software is important, but knowing how the software works or when to use it is equally important. So a good analogy is you won't use a chisel to cut a tree, but you won't use an axe to make a wooden sculpture. And then lastly, identify your matrix, what your benchmark upfront. What are you going to use to know that you've done the right thing? What are your metrics? What are your performance indicators? Because when we get lost into this software simulations mode, running options, and we forget like what are our benchmarks, what are our metrics we're comparing, we are assessing ourselves on. And that's it.
Great. Thanks, Yogesh. That was awesome. Any questions from the floor? Yes, I see a question from Italy Marine. If you can unmute yourself.
I'd just like to make a comment on a broader comment. When it comes to bioclimatic design, beautiful. We're always considering one building, the building, how we design the building, and where the building is with respect to the elements, the sun, the light, the temperature, the wind, and so on and so forth. But never, or very seldomly, I hear talk about the surrounding building. Or what if we put a tree in front of a house, a big tall tree in front of a house? That's part of bioclimatic building and design, according to me. So we just simply omit the human surroundings. We just consider the natural surroundings, and then we design our building. The humans live also outside the building. And if we design the building in such a way that then something gets in the way, another building or whatever, then if this hasn't been taken into account, we'll have some problems anyway. So why is it always that this topic never ever comes into the picture? That's just a question, a broader question, and I would like to see it happen.
That's a very good point. I really enjoyed that question, and I actually had not to justify what you're saying, because I do feel like it's important, but I had a discussion with one of the building control officers a couple of weeks, and we were also talking about external shading, and they were asking like, so how do trees come into the legislation, for example? Can you use it as a shading device? And it doesn't come into the legislation. But from a modeling point of view, I do feel it's like really important, especially if it's, if you're trying to create that environment around your buildings and making use of the existing vegetation. I don't know, Yogesh, if you want to add to that.
No, absolutely. When I talk about context and intuition, I'm not referring to just the building. I did consider including other slides for site, considering your site and urban, like thinking about it more than just your site, but around a whole urban context as well, or a precinct and campus. But I think I was running on too many slides already. But yeah, it's very true. And the context is not just your building. Your context is everything around it, even how your visitors are coming or going to your building. That's also your context. A very important thing when you talk about context is also urban comfort and outdoor comfort, because a very simple example, we were doing this precinct project where it has university buildings. If you think about students, they walk from one building on a campus to another building. They might come from a non-air conditioned building where they've been for an hour during a lecture. They go out for half an hour, 15 minutes in full sun, depending on where they're walking, and they go into a building for half an hour, which is fully air conditioned. That building air conditioned might meet certain comfort criteria, but the people are not going to be comfortable because their environment has changed for 15 minutes before that. They will immediately feel a different, the comfort you have, not the same comfort you've designed the building for. So yeah, so context matters.
Thank you. Nina, you want to ask your question?
One comment is on this issue of trees. I think that there's a big gap in the urban planning and urban design of our cities in terms of general comfort levels, so that we are forced to, as architects, we can only deal with the building, and there isn't a lot of scope for dealing with the environment off-site. So that's just a comment on the previous one. Then I just want to make an observation. It struck me that Yogesh repeatedly referred to this thing of gut feel or knowing your experience or whatever. But I thought I knew a lot, but I even learned a few new things in this presentation. And I think what's important is that we tend to override our gut feel with habit. And we don't always know the finer points. This issue of diffused radiation, I don't know how it works, and I'd love to know how it works, because how could I develop a gut feel for it if I don't understand how it works? And I think that's where these kind of continuing presentations might actually be useful if they also focus on developing people's knowledge about specific aspects a little bit more. The question I'd like to ask Yogesh is whether you actually observe in your practice, working with architects and so on, whether often the gut feel is misplaced.
Hi Nina, how are you?
Thanks.
No, it's a very fair comment. I guess it's quite hard for me to answer that, because our role typically on projects is to come in and challenge what architects or engineers would kind of propose. That's kind of our role, is to see how we can challenge or make it better. But in generally, we found out, like, you know, the gut feel is usually quite right. And by us coming in and giving them a little bit more information, challenging them a little bit, like you mentioned, like telling them a little bit about diffuse radiation, which they might not know, the direction then changes to the gut feel is not wrong, but just gets better essentially. And we get to a better, more refined solution.
Yes,
Did
thanks.
that answer your question, Nina?
Yes, thanks.
Awesome.
Yeah.
And thanks for bringing it up. That
Yeah.
I'd love to hear that you learned something today. And also great to hear, like, pointing out like the places where you didn't understand, and then we'll try to make it more clearer, maybe do another session on it. Cool. Awesome. I just want to answer some of the questions in the chat box. There was a comment from Jackie LaRue. It's very important to go back to your designs and know how successful they are from the people who use them after a year, so you know what you worked and what does not work for the next project. I think that is definitely important, especially in the field of architecture and creating thermally comfortable buildings. And then Megan is pointing out, fantastic point from Nina. I feel the same, having designed sustainable buildings over 30 years. I love learning new things and perfecting my craft. I love this forum for exactly that reason. Thank you. Yes, there is another question from Italy Marine. I assume that's not your name, but that's how it shows on my side. So.
I'm Roberto. Hi.
Hi,
Just
Roberto.
a quick question. I see on the slide presentation that the sponsor is ENVIROCRETE Bioclimatic Building. Can we have an idea what ENVIROCRETE actually does, since they have in their logo the bioclimatic building?
Yeah, I don't know what time you came in, but we did show the video in the beginning.
I came in rather late.
A little late. Okay,
Sorry.
cool. No, I'll send you the script and I'll send you the link to the video. But basically, ENVIROCRETE is a particular material which combines concrete and wood pellets and waste wood pellets and combines them together to create a thermally very well insulated piece of material that is prefabricated, so then it sort of gets assembled on site. So yeah, that doesn't answer your question immediately, but definitely I'm happy to share the link, or go to their website. I guess that's more important. Go to their website and they have quite a lot of information about the bioclimatic architecture of the system.
Thank you very much.
Great. If there's not any more questions, I'm gonna go through the last couple of slides on my side. So I just want to tell you about the next webinar. You can already register for it. Lisette's just posted the link. It's going to be about sustainable urban drainage systems. That might sound a little bit technical, but we're going to make it very practical. So it's not just for civil engineers only. It's really focused on everyone. So don't let the technicality of the title put you off. And May, we're still discussing what we're going to do. We might gonna change it around a little bit and do like sort of a panel discussion and have a couple of people on the webinar with some interesting topics to discuss. So in closing it off, thank you to Yogesh for entertaining us today on a great presentation on bioclimatic design. I think we all learned something new today, so it was definitely great to have you here this evening or this afternoon. A really big thank you to our sponsor, ENVIROCRETE. We really appreciate your contribution to this. And just maybe to just summarize, ENVIROCRETE is a South African company at the forefront of sustainable construction, and their commitment to building a greener future is very amicable and really focusing on affordable housing solutions with minimal environmental impact. So thank you so much for assisting us with this webinar. Really appreciate it. And just a reminder to follow us on our YouTube, LinkedIn, and Eventbrite. So with that, have an amazing long Easter weekend. Regenerate yourself, and we hope to see you next month again on this webinar. Thank you so much, and thanks for all your comments in the chat. Love to get feedback that way. Thanks, guys.
Thank you, everyone. Bye.